Welcome to Research in Focus again. I'm Gretchen Huizinga, and I'm joined now by two heavy hitters in systems and networking. Albert Greenberg, the CVP of Azure Networking, and Victor Bahal, Director of Mobility and Networking at Microsoft Research. It's great to have you both with us today. There's many projects that you've both been involved in bringing to life, and I'd like to hover at the 10,000-foot view, kind of in the cloud, if you will. And talk about the big issues and big problems that you're instrumental in bringing to life. And I'll start with you, Victor. If the cloud is too big to fail, how are researchers dealing with the challenges of scalability, reliability, and availability, even as Moore's Law breathes its last few breaths?
I don't know if cloud is too big to fail. I think we don't want it to fail ever. But yeah, obviously with scale, the challenges become extraordinary. So for example, we have millions of devices that are connected to the cloud. And especially if you think about networking, and all these devices have to move packets from one point to another, and they are across the globe, across the entire planet. We have more than 30,000 miles of lit fiber, for example. We have hundreds across the globe. We have more than 100,000 miles inside the network, inside the data centers. So yeah, so then when you think about these problems, and anything can go wrong any place, and if it goes wrong, you can actually bring down massive number of businesses, or a large portion of the cloud can go down. So this is a very stressful situation if you think about it. And so this requires discipline in the way you approach it. This requires science, so that you can reason about things when they fail, and this requires the ability to recover from failure so fast that the customer doesn't actually realize that. And so when you think about these problems, you start to think that it stretches every bit of technology that we have built in many different spaces. So from protocol design to sort of availability to sort of fault tolerance, all this stuff gets very, very stressed. And so researchers tend to find these problems, and then tend to, once they've identified, they work on it. So there's a slew of problems I could talk about, but you want to?
Yeah, no, I think that's great. I mean, it's a challenging system before the cloud, and now that we've got all the additional layers, it makes it even harder and more challenging for researchers. Albert, you go way back. The two of you go way back, actually. But Azure Networking and Microsoft Research go way back together. The beginnings of many projects were in Azure. Actually, I think you were incubated there too, if we will. Yeah. How would you characterize the relationship between systems research and its reification in products today?
Well, yeah, so I also, as you mentioned, started in Microsoft Research working with and for Victor. And what we knew at the time is that Microsoft was going through a transformation. I mean, where we are the new platform for everything in computing and storage and networking is the cloud. It's amazingly exciting, and that's why reliability is so central to it. So we really are transforming everything in life and work in this field. And we could tell at the time that what we had to work with, the raw ingredients, would not work out for us. We had to invent a lot. And so we had to team with the product groups inside Microsoft, incubate and prove our ideas, as well as other industries, and consume components and hardware and software from them, and then put together this new platform for the entire world. And that's why we're so excited every day to go to work, is we have a huge amount of work, other people's work running on our cloud, and it's growing.
How does that, when you have other people's things that you have to incorporate with your things, what particularly does that do to the big picture?
Well, a good example is what we call disaggregation. So we in this infrastructure, it used to be, for example, in networking, you would buy a box, and in this big box there would be the power, the software, the hardware. It was one proprietary monolith. Right. And in the disaggregated world, where we have to achieve incredible levels of reliability and safety and so forth, we need to know everything about what's in that box and control it ourselves. But we don't necessarily build all the hardware. So we have to, go to class, work with partners. In fact, one of the first classes I took when I was in Microsoft Research was with one of our hardware partners, and they were revealing the theory of operations of their parts. And sitting next to me are the traditional networking companies, Cisco and Juniper and so forth, and then here's Microsoft understanding everything. And so we could take, I knew that something was changing, and that was the opportunity that disaggregation afforded us.
Right, right. Victor, Microsoft just announced the Open Network Emulator, which is a big, big story. But emulation is not a new thing. And so how does the Open Network Emulator bring us to the next level of reliability? What's new about it?
Yeah. So, both of us have talked about reliability or availability, right? So I just want to make that point crystal clear here. When we have a lot of our customers depend on us, that should mean something, and Microsoft's name means something. That means that we will be up for you 24/7, 365. Nothing will happen. And as Albert was pointing out, sort of networking is the substrate which keeps the cloud alive. Without networking, you would just have servers, and that's not good enough, right? So then, as you had asked me in the earlier question about what sort of challenges researchers do, so availability and reliability is a massive challenge. Stepping back from Open Emulator just a minute, there's a field of research around network verification, or in fact software verification. The idea there is that before you touch anything significant, like inside a network or server, you want to verify that it won't have an impact. So we built this Open Network Emulator, and it is so good, just to sort of praise ourselves a little bit, that when, and I think Albert can testify to some of that stuff, what I'm saying now, because it's so good that when operators or engineers, network engineers, go and change something somewhere in the world, anywhere in the world, right, across the planet, they actually don't know if they're changing the network or the emulator, because it is it mimics the network so well that they can't tell the difference. But the beauty is that they are actually changing the emulator that we have built, and we then test out everything before we will go and touch the network. And by testing out everything before we touch the network, we can ensure that it works. In the past, that was not the case. In the past, people would go and make some configuration changes here and there, and in their head, the logic would be fine, but the interdependencies are so large and so complicated that if you touch something in one place, it can have impact somewhere else in a big way, and it's sometimes even beyond human capacity to understand that. But the emulator avoids that. One more thing I would like to say here is that the value of this is so large that we actually thought that it's actually good to share it with the world. So we're making it available. We are maybe letting, for example, the other industry folks to see how it is built. We want our students who are in graduate school and trying to do work on large scale networking, be able to use the emulator to do their research on that stuff. So yeah, we are very excited about all this.
So the Open Network Emulator is open source?
Yeah.
Can you speak to that a little bit about the rationale behind that?
I will, yeah. So let me just talk about how this thing operates. If you imagine you wrote a piece of software, and it could be for a commercial router or one where our software, and let's say a Cisco or Juniper or a Sonic, which is ours. And like you can imagine, like the brain of that thing goes to sleep, and usually when it wakes back up, it's the real hardware there, and it's like manipulating, physical hardware. This thing wakes up and it thinks there's the hardware there. It's pretty, it doesn't know. It's that we virtualized the hardware, so it's actually exactly doing what it would do in the physical world. We've faked it out to think that the real hardware is there. That means there is no modeling. It is the real thing running. And that means that if you watch people operating on it, and they can't tell either. Right. It is identical. It's woken up in the cloud. Now, the other thing that it illustrates is the need to use the cloud to build the cloud. There was no technology ever to sort of have this thing wake up and think it's on a physical, but we virtualized everything in the cloud, and now it can do it. And then we can build networks of thousands and thousands of these switches virtualized, and they're talking to each other. And we can find bugs. We found hundreds of bugs before they ever got out. No one ever found out about them, and we did a lot of work without. So it's really like virtual reality, but it is the real thing running in Azure.
Yeah, and then I'll just add to that a little bit. So just to sort of make this even more strong for people who do understand some of this stuff in networking. So the past had been a lot about modeling, right? Modeling protocols, in fact, and then taking a spec and maybe turning that into a model and then using that to do some verification. This eliminates all that. So as Albert has very, very nicely articulated, that by removing that sort of thing, we are, as he said, any issue that the hardware vendors may have, that's all captured in that emulator. And that is why we have such faith and dependency on this, and it works.
Has it been deployed widely already, or?
Yes. So it's deployed widely, and like 2 hours ago, I was watching it running right before
So
a major maintenance. We don't want to touch anything without running this emulator, and it's not that we didn't learn anything here, that like we didn't fix any bugs, but we don't always know the default behaviors or the exact environmentals. So it is part of our release process, part of our management of change process to run it all the time. And by the way, there's a lot of innovation beyond just faking out the software to think it's on physical. There's other innovation because it could burn up too many hours in the cloud. So we have to figure out smart ways to make it economical to run it all the time.
Yeah, there's also scoping, like how big a network do you emulate and things. Yeah, so there are many, many pieces of.
I would imagine you've got a lot of feedback on this from the deployment. What's the feedback you're getting from customers and other businesses?
So the beautiful thing is we've this year done a project called regional networking, where we moved more circuits in weeks and months than we ever moved in the history of Microsoft before, and customers didn't notice. It just worked, and that's because we rehearsed, we got good at it, and we found the bugs through this emulator before doing it. So customers don't feel a thing. The industry is super excited by it. The networking industry has seen some papers and some blogs, and they want to consume it. And you could not do this without the cloud. That's why it's now. Yeah.
Right. It's enabled this to happen.
Yes.
Yeah.
But also because it needs to happen in the cloud.
That's right. I mean, we need all these cloud technologies to build and design and run the cloud.
So just it's a real good collaboration between research and product too. So
Yeah.
just add. So the other question you asked was about traffic flow and how it's increasing and how it's impacting everything. So at the moment we have capacity. We have a lot of capacity. We have invested in it. We are managing it. It's all good. But you're right. Things are growing faster. And as we make our networks more accessible, more broadly available across the planet, it's going to keep going up. So that does present problems to us, and it also presents our challenges of how we're going to grow our networks with it. So I have a lot of faith in optical technology. And we have a tremendous amount of investment in Microsoft research on that. So there are labs, there are people in our Redmond lab, which is where I live, working on this. And then we have very, very smart individuals in Cambridge lab who have been working on this for a very long time. But to just sort of give you a sense of how this means, so with just single wavelengths, we can move tens of terabytes or terabits per second of traffic. Now, we have and optical is very much like wireless, and wireless is a very mature technology, and so you can apply these wireless things that we've learned in the wireless space into optics too. So for example, recently, one of the researchers in our group figured out that by changing the modulation, you can go from 100 gigabits per second to 150 gigabits per second without really changing any hardware. And same fiber, same wavelength, and so similarly now we're looking at things that using multiple wavelengths for that. So even though this is going up, but we are working very hard to solve these problems of being able to sort of scale up. But I have a tremendous amount of confidence that we can measure up and match and provide enough bandwidth to the world even as the demands go up.
Right. So circling back to the product and research symbiosis, as it were, and Victor's talking about the tension between risk and, let's call it, a product deadline. Do you build risk into the product roadmap situation?
Yeah, we absolutely do. We think about risk of all types, all the time. That's part of the driving that risk down. And it's one of the greatest ways to manage that is just leverage Microsoft Research. I mean, they have the mind space, they have the tools, they have the expertise, and they have the grit to work with us and solve the I think problems that have never even been seen before, and then see their ideas implemented. So to me it makes no sense not to be fantastic partners with Microsoft Research, and so it just happens, and it's a unique resource for Microsoft. I don't think anybody else, no other company in the world has something like Microsoft Research.
A dozen PhDs that you can call on to say, hey, how would you fix this?
Gretchen, I honestly feel that if you look at all the cloud providers, in networking, we are the best. And I say it in a very, very confidently. And part of it is just because, we work very well together. And, like I said, many researchers are now in product, and Albert also went from there. We sort of understand the pains and we understand the constraints that they work in. And so we work very well. And it's been great.
Cool. Well, as we close, I just want to get from each of you what your goal or vision about this looks like in the future. Let's just say that a network world and all the things that you're doing are wildly successful. What does it look like in the real world in the future?
We are creating the future, I think. We are imagining what that's going to be like and building it every day. What we are achieving is in part reliability, but we're also achieving security, fantastic speed. Everything works fast and works as designed, and it's supportable. You don't have to figure it out. There's no friction. So I think those are common things where we just keep getting better and better. But I think to some degree, as the whole world moves into the cloud, just as we in the case of One had to use the cloud to build the cloud, we're seeing the new capabilities enable us to do new and better things, and we are, and so that I think we will just keep expanding in greater and greater circles, and I think we'll change the hardware, we'll change the software, we'll change the data science, we'll change whatever needs to be changed to realize this vision where all of the world's computing is running on the Microsoft cloud.
Victor?
So what can I say? I shared this vision with Albert, but here's what I'll say. I would love to eliminate Albert's job. So
You hired him first, you're getting rid of his job later.
So, I mean, joking aside, really what I mean here is that there is, you asked for the vision. Of course, this is a very difficult thing to do, but we want to build the most reliable, the most secure, the most accessible, the low latency, fastest network in the world, in the planet. And we want to make it so that we want to build technologies that if something bad happens, it heals itself. We are able to, the systems are smart enough to be able to sort of say where the problem is, how do I fix it by itself, potentially alert it, and then just fix itself up. And so I was joking about it. I think we need Albert like crazy here, and this is, but you get the point. So in some sense, That's a very hard challenge. And the interesting thing to me is that as you build this stuff, you actually learn so much, you can start to apply it in other domains as well. So it's not just about networking. A lot of the data science, as Albert was referring to, a lot of the new science that we are creating is very applicable to other spaces as well. We haven't talked much about wireless too, but the last hop, a lot of the world is mobile now. And everybody's using smartphones and laptop, moving around. And so we have to fix that. We have to make that as great as we are making the cloud great. So there's work to do, but we are getting there.
I think you both have jobs for a while yet, anyway. And I'd have to say there's a lot of things that don't happen to us that we don't know that you made not happen to us. So I appreciate that. And I appreciate you both coming in here, Albert and Victor. It's been insightful and inspiring.
Thanks, Gretchen.
Yeah. And thank you for joining us on Research in Focus for this session. We hope you'll come back for the next one.